This is the procedure for the second hanging calibration for the GeoShot 2 tool. Step 1. After magnetic calibration, remove the tool from the Helmholtz coil and attach it to the hanging apparatus. Step 2. Before hanging, remove the batteries from the tool. You will use the nearby power supply to power the tool. Adjust the right side of the supply to read from 5 to 7 volts. Step 3. Connect the tool to the black box beside the computer using the Leno plug. The wires are color-coded, so connect the wires of the same color together. The power wire coming from the black box will be white. This wire should be connected to the red wire and the cable attached to the tool. Step 4. Make sure the toggle switch on the black box beside the computer is pointing to the hanging side, and that serial cable is connected beside it. Step 5. When you have checked to make sure all connections are made properly, open the program named Hercules on the laptop. Step 6. Click on the Serial tab and set the following items. Name to COM1, this will not always be correct, you may have to find it. BAUD to 9600, parity to none, RTS and DTS would be unchecked, handshake to off, mode to free. Under the Special Characters tab, select Text Mode, DEL, EEOLs to unchecked, Local Eco checked, and Transmit to CR max. Step 7. Before starting the calibration, make sure the tool is as vertical as possible and not swinging. Click Open to open the COM port in order to communicate with the tool. In the workspace, perform the following. Type CONN, press Enter, getting response MES2, then type MCALI, press Enter. Response will be current accel readings for the X, Y, and Z. Step 8. The purpose of the hang calibration is to get the X and Y sensors or accelerometers to read 0 and the Z accelerometer to read 1. Step 9. It is important to make note of the numbers for Z, whether they are positive or negative. The memory locations where the coefficient corrections are to be written will depend on whether the Z accel numbers are negative or positive. For the negative numbers, the memory locations are DC, DE, and DA. For the positive numbers, the memory locations are BE, C6, and C8. As the rule of thumb, if the tool is hung by the end with the Leno plug, the number for Z should be negative. If the tool is hung by the battery end, the number should be positive. In addition, if the sign of the numbers for X are the same as for Z, then you will need a negative number to make X 0. If the sign of the numbers for X are opposite those of Z, you will need a positive number to make X 0. This is true for Y as well. Step 10. To perform the calibration, take the average of the accel data. Change the sign of the number if required, then multiply by 32,768, which is 2 to the 15th. Convert the resulting number to hexadecimal and record the number. Step 11. Repeat Step 10 for the Y accel data. Step 12. Take the average of the Z accel data. Then take the inverse of this number by dividing by 1, then subtract 1, multiply the result by 32,768, and convert the resulting number to hexadecimal, again recording this number. Step 13. The hexadecimal numbers you recorded in step 10, 11, and 12 will need to be written to the memory of the tool. Assuming the tool was hung by the leland end, you will need to write these numbers to memory locations DC for X, DE for Y, and DA for Z. To write the numbers to the memory locations, do the following. Type WRODC, then the hexadecimal number from step 10 above, getting the response MO3. Then type WRODE with then the hexadecimal number from step 11, getting the response again M03. Then type WRODA, then hexadecimal number from step 12, getting again the response M03. Then type RESE, then press enter, getting the same response M03. Then type CONN, getting the response MES2. Then type MCALI, press enter, and then getting the response of the current sensor readings for X, Y, and Z. Step 14. The new numbers for the X, Y, and Z accelerometer should now be 0, 0, and 1, respectively. Step 15. Additionally, check the readings for the inclination. This should be 180, and the G total reading should be -1 or close. Step 16. Now flip the tool 180 degrees and hook the tool to the other end. Step 17. With the tool flipped, repeat the same procedure outlined in step 9 through step 15. Assuming this time the tool was hung by the battery end, the memory locations will be BE, C6, and C8. You will be writing the value for X to BE, the value for Y to C6, and the value for Z to C8. Step 18. Once again, when you recheck the numbers, the value for the X and Y should be 0 or close, and values for Z should be 1. Step 19. Additionally, when you check the inclination, it should be 0. The G total reading should be 1 or close. If the numbers are not matching up, double check your calculations. It is possible you have made an error. Step 20. Check the serial number of the tool by typing in SERI, then press enter. The tool should respond with the serial number assigned to it. Check to make sure this number corresponds with the paperwork for the tool and record this number. Step 21. Next, type in VERS and press enter. This should bring back the current version of the software being used with the tool. Again, verify the software is current and record this number. Step 22. Type VATTV and hit enter. The tool should respond with the voltage it is currently reading. This value should match the voltage shown on the power supply within 0.1 volts. Step 23. Verify the tool parameters by typing PARA and hit enter. This should bring back all the calibration parameters for the tool. Go through the different parameters to check to see if any show all zeros. Step 24. If the X, Y, and Z sensor readings show correctly on both sides, if the tool and all the parameter readings are acceptable, the hang calibration is complete at this point. Step 25. Turn off the power supply and remove the tool from the hook. Fill out the necessary paperwork for the tool and return the tool to the workshop for field qualification. Note: if you made a mistake while writing information to memory, you can type WROXXFFFF with the XX being the memory location, for example DE. The tool will ignore the previously written data and return to the original data it displayed. It is important to pay close attention to the sign of the numbers for the Z accel while hanging so that the information can be written to the correct memory location.